You know, it's something you do hundreds, maybe thousands of times a day without even thinking about it. You click, and boom! In a split second, a web page, a video, a whole universe of info from the other side of the planet just appears on your screen. It honestly feels like magic, but it's not. It is an absolutely incredible, high-speed race that happens faster than you can blink. So what's really going on during that journey? Let's break it down.
Right, this is the big question, isn't it? It's really at the heart of our modern world. Today, we're going to follow that single click on its lightning-fast journey, all the way from your finger, through this hidden world of cables and routers, to a server thousands of miles away, and then all the way back. So let's start at the very beginning.
Every single epic digital journey, and I mean every one of them, kicks off with a simple physical action. That one little click from your mouse or tap on your screen, that's the starting pistol for this unbelievably complex, high-speed race.
The second you click, your computer does something amazing. It translates that physical pressure into its native language, a digital signal. And what is that? Well, it's just a stream of on and off electrical pulses that we see as zeros and ones. Literally everything you do online, every photo you like, every message you send, it all starts as this simple binary code.
Okay, so now we've got our digital message, our string of zeros and ones. But it's kind of trapped inside your computer. To get out into the world, it has to make its first leap. And for most of us, that first jump is wireless. And this is where Wi-Fi comes in. You can basically think of it as a really smart radio that takes your data, those zeros and ones, and just broadcasts it through the air. What this does is create your own private little network bubble, what's technically called a local area network, or LAN, right there in your home or office.
The director, the person in charge of this whole local operation, is your router. I love this analogy. It's a traffic cop. It catches that signal flying from your device and directs it where it needs to go, pointing it straight towards the on-ramp for that massive public highway we call the internet.
So this is a really critical moment. Your data has to leave the cozy, safe little bubble of your private network and get ready for the big journey on the public internet. But to do that, it needs a translator.
And here it is, the modem. Its name is actually a huge clue to what it does. It modulates and demodulates. So why does it need to do that? Well, it's because the digital signal from your computer can't travel over the old-school analog stuff like phone or cable lines. The modem's entire job is to be the perfect, seamless translator between these two different languages.
And you can see that brilliant translation process right here. Your computer sends its digital signal to the modem, your modem modulates it, changing it into an analog wave that can travel on the physical line, then way over at the other end, another modem instantly demodulates that wave, converting it perfectly back into the original digital signal for the server. It's just a flawless, elegant round trip.
So, what kind of physical road does our signal actually travel on? Well, there are really three main on-ramps to the internet. You've got the oldest one, DSL, which cleverly piggybacks on the existing copper telephone lines in your house. Then came cable, which uses the very same line that brings you your TV signal. But the real game changer? That's fiber optic. It doesn't use electricity at all. It sends your data as literal pulses of light through tiny glass tubes.
And this is where things get really interesting, because speed is everything. The jump from those old DSL phone lines to cable was huge. A coaxial cable can shuffle data about 80 times faster. For its time, that was a revolution. But it is absolutely nothing compared to what was next.
I mean, just look at that number. Not 80 times faster. We're talking 26,000 times faster. That's just mind-blowing. And that is the raw power of using light. When you switch to sending data as little pulses of light, you get the digital superhighways that our entire modern world runs on. We're talking everything from streaming 4K movies without buffering to playing games with people across the globe in real time. The takeaway here is super simple. The physical medium you use, yeah, it matters a whole lot.
All right, so our data is now zipping along these superhighways, literally at the speed of light. But the internet isn't one straight road, right? It's this mind-bogglingly complex web of interconnected paths. So how does our tiny piece of data know which turn to take to get to the right place? Simple. It needs a rule book.
And those rules are called protocols. You can think of them as the universal traffic laws of the internet. They make sure that every single device, no matter where it is in the world or who made it, can talk to each other effectively. And the undisputed king of all these protocols, the one that really runs the whole show, is called TCP/IP.
Okay, the way TCP/IP works is it's pure genius. Think of it like a super efficient postal service. First, the TCP part takes your big message, let's say it's a photo, and it chops it up into thousands of tiny numbered pieces called packets. Then, the IP part comes along and stamps the destination address on every single one of those tiny packets. Then they're off. They get sent out into the internet. And here's the really cool part. They might take completely different routes to get there, whichever is fastest. Finally, when they all arrive, TCP's job is to look at those numbers and put them all back together in the perfect order. This whole process is the secret sauce to the internet's incredible speed and resilience.
So what are these superhighways that we keep talking about? It has a name, the Internet Backbone. And it's not some abstract concept like the cloud. Oh no, it is a very real, very physical network of massive fiber optic cables, some as thick as a garden hose, that crisscross the entire planet. Hundreds of these cables are just lying on the cold, dark ocean floor, connecting continents and carrying pretty much all of the world's data as tiny pulses of light.
So, we followed one little data packet on its incredible physical trip. But how do all these pieces, all the cables, the routers, the millions and millions of computers, fit together to make a system that actually works? Well, to get that, we need to zoom out a bit and look at the network's blueprint, its fundamental design.
The first part of that blueprint is something called network topology. It's a fancy term, but it really just means the network's layout or map. It's how all the different devices are physically or even logically connected to each other. Is it a straight line? A big circle? A web? That's what topology defines, the actual shape of the network.
Now, while there are a bunch of possible shapes, the one you'll see pretty much everywhere is the star network. It's so simple and so effective. Every single device, your phone, your laptop, your smart TV, connects to one central point, like your Wi-Fi router. That hub then acts like a central switchboard, making sure all the messages get to where they need to go. Your home network, it's a perfect little example of this.
So if topology is the map, the next piece of the puzzle is the network strategy. This defines the rules of engagement, how information and resources are actually coordinated and shared across that map. It's less about the physical layout and more about the power dynamic, who asks for information and who provides it. And the strategy that powers basically the entire modern internet is called client/server. It's pretty straightforward. In this model, your device is the client. It's the one making requests. So when you click to watch a video, your client sends a request to a really powerful centralized computer called a server. That server's whole job is to find that video file you want and serve it back to your device. From social media to your online banking, this is the fundamental model for how we get just about everything online.
So there you have it, from a physical click to a digital signal, sent by radio waves to a router, translated by a modem, shot across the ocean floors, pulses of light, broken into 1,000 tiny packets that magically reassemble on the other side, all just following the simple rules of a client asking a server for something. That is the incredible, invisible dance that happens every single time you click. Our whole world is literally built on this foundation. Which, of course, leads us to the biggest question of all. As this network gets even faster and smarter and more connected, what amazing new worlds will it unlock next?